All right, so section 5.9, solving rational equations. We call this the advanced section, okay? And the reason why we call it the advanced section is because look at the denominators, okay? Let me show you the question number 2. Notice the denominators are no longer just like 4x or x squared, right? Now we got expressions, okay? So that becomes a little bit tougher. Not a lot, but a little bit tougher. It does require us to do a lot more work to try to find our least common denominator. But look at like number 1. That's trinomials. I got to factor that stuff, okay, using the x method. I'm going to have to do that first, okay? So you can see how, here's number 3. Okay, look at the denominators there. Look at the denominators for number 4. Notice how for number 4, this right here doesn't even have a denominator. So what do we do in that case? We are going to work on that today together. And let's see, how many questions did they give you? So just 6. So there's only 6 problems, okay? So what I'm going to do is, looking at all 6, I'm going to probably do number 4, number 1, and I got to give you one of those. Maybe number 3. No, we'll do 1, 2, and 4. 1, 2, and 4. All right. We'll wait for number 1 at the very end because that one looks like it might require more work. We'll see. So let's start off with number 2. Okay. So again, we are basically doing what we did yesterday. Is we're going to try our best to find a common denominator, then multiply by that common denominator, so that we could cancel out all those fractions, right? We want the fractions to disappear. And then once that happens, then usually it gets a little easier for us. So just like what we did yesterday, I'm going to write down all of my denominators. And then what I want to do is I want to ask myself, how can I factor them, if possible? So I look at 3x squared minus 4x. What can I factor out of 3x squared minus 4x? Well, I can't take out a 3x squared because 3x squared and this 4x do not have a 3 in common. An x, right? Just an x. So x times 3x minus 4. Can I factor the second one? No, right? There's nothing in common, right? They have a 3 and a 4, or just one of them has an x. So this would just be 3x minus 4. Nothing to do. I just put in a parenthesis, just on purpose. And what about the last one? Well, it's the same as the first one, right? So I should be able to factor it like this. Okay, now why do we do that? Because this is where we start choosing what they have in common. No problem. So let's see. Let's find my LCD. So my LCD. They all have a 3x minus 4, right? And it's all to the first power. It could be like a second and a fourth power, but they don't have that. It's just all to the first. So I'm going to put 3x minus 4. That's one thing that I noticed that's there. I also noticed there's an x all by itself. Maybe they don't all have it, but remember what I told you? You have to list everything you see. Okay? And what's the highest power on that x? Well, this is a first and a first. So the highest power on the x is a first. Okay? That's my LCD right there. 3 times 3x minus 4. Okay, so you take the x's to the highest power, so x to the first. Then you take your factor, 3x minus 4. Okay, to its highest power. So you're going to want to list all of the factors that you see. All right? List all the factors. That's going to be your LCD, and list them all to their highest power. So, what do I do with this? Well, first off, let me rewrite. I'm going to kind of highlight this so we know this is important to us. Let me rewrite the problem, but when I rewrite the problem, I'm going to rewrite it in a factored form. So, 3 over x times 3x minus 4 plus 1 over 3x minus 4 equals 1 over x times 3x minus 4. Now, if you're wondering where the heck did I get that information, the factors right here. Remember, we factored them. We factored them. So that's where I got that information as to how they look when I factor. Now, if you guys remember yesterday, my next step was to multiply everything by my LCD. So, my LCD is x times 3x minus 4. And I'm going to multiply that times 3 over x times 3x minus 4. Plus, notice I'm using brackets because there's parentheses already, so I just changed the type of parenthesis. Plus, let me multiply by my LCD, x times 3x minus 4 times 1 over 3x minus 4 equals x times 3x minus 4 times 1 over x times 3x minus 4. So again, remember I told you people don't like these problems because they end up getting really long if you show all your steps. Here's an example of what I mean by they get really long. Okay? But I don't know if you guys remember, but I told you guys yesterday, I feel like these are easier problems than yesterday's. Okay? Why do I feel that way? Look at how easy it is to tell what gets canceled. It's not like I'm reducing numbers. I'm literally saying this x with that x and 3x minus 4 with that. Right? For the next one, what can I cancel? The next fraction. Yeah, the 3x minus 4. Gone. What about for the next fraction? What can I cancel? Yeah, everything, right? All this, all that. It's so much easier to cancel out in this one. Okay? So, here we go. The first fraction is just 3 plus x times 1 equals 1. I mean, it's kind of hard to believe that after that big old mess, all that's left is a 3 plus x times 1 equals 1. All right? So this is 3 plus x equals 1. Let me just kind of move that over there. If I subtract 3 on both sides, I'm going to get x equal to negative 2. And there it is. So it's the same like yesterday's work. It really is. It's just that now the factors get a little bit more intense. They're not as simple as just like, oh, 4x squared, 5x, and an x. Or like, no, it's now you got to factor some stuff out and you're going to have to cancel things out based on that. Okay? So that's why we call this the advanced section, because it's not as easy as yesterday's in terms of factoring. This one requires you to do a little bit more work in the beginning. That work was right here. All this stuff up there. Okay? That's work that I had to do in the very beginning before I even started doing my problem, just to get ready to do the problem. Okay? So that was like a prep, right? It's kind of like baking the cake, right? You have to prep it first, and then you put it in the oven. You just don't throw the box in there and hope a cake comes out, right? So you got to prep it first, then you get to do it. So that's question number 2. Any questions on this one? I know it's kind of a lot of work, but is there something you guys didn't understand that I can kind of go over really quick? So maybe after the next one, we'll see. Question 4. Let's do question number 4. Now notice, for this problem, there is an over 1, okay? That 1 over 1. I know it doesn't have a denominator, so you can always write a 1, okay? So, let's write down all of my denominators. R squared minus 4r, a 1, and an r squared minus 4r. All right, what can I factor out of the top one? R squared minus 4r. What can I get rid of? Or what can I take out? An r, right? Yeah, so an r times r minus 4. Notice that's going to be the same for the bottom one. Can I factor a 1? If it's just a 1? What do you guys think? Just for a 1. All right, so I see a lot of people kind of shaking their heads. Yeah, you can. So there you go. So, knowing that, then what's my LCD? Or remember, write down all your factors. So I need an R. There's an R out there. What's the highest power on that R from here? Just the first, right? So it's just going to be R. I see a 1. And I see an R minus 4. And the highest power on R minus 4 is just a first. So that means my LCD is this right here. R times R minus 4. Okay, that's my LCD. So don't forget about that. Right now we're going to multiply everything by that. So let me rewrite it in factored form. So this will be R plus 1 over R times R minus 4 equals 1 over 1 plus 1 over R times R minus 4. Remember, this is me just getting it ready, right? I'm getting it ready so I can start canceling stuff out. Now I'm going to multiply that big equation by my LCD, which is R times R minus 4. So here we go. R times R minus 4 times R plus 1 over R times R minus 4 equals to R times R minus 4 times 1 over 1, but nothing really to cancel out, right? Let me actually do that. And then plus R times R minus 4 times 1 over R times R minus 4. So right now we're probably going to have to move the work over to the side, but let's go ahead and cancel some stuff out first. Look at my first fraction. What can I cancel out? All right, so the whole thing you're saying. So yep, everything's gone. Can I cancel anything out with the second fraction? No, it's just a 1, right? So I'm just going to leave that alone. And what about the third fraction? All right, so same thing, right? R times R minus 4. So let me write down what you're supposed to get. So I'm going to kind of move to the side, okay? You're supposed to get R plus 1 equals 2. So it's going to be all right here. R plus 1 equals to R times R minus 4 plus 1. So I'm going to go ahead and distribute. So R plus 1 equals R squared minus 4R plus 1. And what I'm going to do is I'm going to move all of those terms on the left side over to the right side so that I can make it 0 on the left side, okay? So I'm going to subtract 4. I'm going to move it this way, so I'm going to subtract 4. And I'm also going to subtract 1 at the same time, okay? I'm going to do 2 steps at once. I'm going to subtract R, and I'm going to subtract 1. So this is what I get. 0 equals to R squared minus 5R, and 1 minus 1 is 0. So there we go. Okay? So I have that as my result. Now I got to solve for R. I don't know if you guys still remember solving for normal polynomials. It wasn't too long that we did this. What you're going to want to do is factor and then solve. So I can factor out an R from this one. Okay? And once I factor, I can start to solve. I can say, oh, look, R equals 0 or R minus 5 equals 0. Remember, you can do that once you have your factors equal to 0. You can always set this up. Once your factors are set equal to 0, you can split them up into 2 smaller pieces or 3 smaller pieces. So r equals 0, I mean, we're done with that. There's not much I can do there. But here I can add 5. So r equals 5. Oops, sorry about that. All right, so a bit of a computer glitch there, but it's fixed now. You see the two answers. If I go back to my multiple choices, you should see that there are two solutions. Where are they at? Right here. Wait a minute. What did I get? Oh, wait. It is r equals 5. So notice here are my two answers. Ready? Let me give you the two answers. R equals 0 and r equals 5. Okay, those are my two solutions. But take a look at my options. Okay, if you look at my options, notice I got 0 and 5. It's not this one. It's not this one, right? It's not this one. This one has 5, but no 0, right? So did I do something wrong? Well, not entirely. The answer is right, but remember how yesterday we talked about there are certain numbers that you cannot use, or else it becomes division by 0, right? If I were to let 0 be an answer for me, if I let 0 be an actual answer, what happens right here? R squared minus 4r. If I plug in a 0, what happens here? Yeah, this becomes a 0. Can I divide by zeros? No. So what you got to do is say, this does not work. So my only solution can be 5. Okay, those were called extraneous solutions, right? Numbers you should not be using. So after you find your answers, check them. If you don't find yours, if you're like, I know I did it right, but I don't see a matching piece, check your answers and see if one of them is an extraneous solution. Okay? So we're going to do one more of these things. I know these take a while, and my apologies for that, and thank you for sticking with me. We're going to do one more, though, which is considered, right, the difficult one, mostly because it has trinomials, right, on the bottom. So question number 1. I'm going to rewrite it to the side because I'm not going to have enough room to do all my work right there. So I will rewrite it on the side. So let me just write this out really quick. So what is it? V squared plus 2v minus 24. All right. So this is number 1. 5 over v squared minus 2v. I think I said that right. I may be wrong. Let me go check. Plus 2v minus 24. 1 over v plus 6. And then the other part was 1 over. Okay, so... All right, so there's the problem for question number 1. Now remember, I have to get all of my denominators and I have to factor them, okay? Thankfully, 2 of those denominators are the same, so once I factor one, I factor both. And the other one, v plus 6, is not factorable, so that one's done. All I got to worry about is factoring v squared plus 2v minus 24. So v squared minus 24. My other one is v plus 6. And then the last one is the same as the first. So let's factor v squared plus 2v minus 24. So I'm going to do an x method for that, okay? Because it's a trinomial. Here's my a, my b, and my c. So a times c is negative 24, and b is a 2. I need two numbers that multiply to negative 24 that add up to positive 2. what do I get? All right, so negative 4, positive 6, perfect. So that's going to be v minus 4, v plus 6. So let me put that right here. V minus 4, v plus 6. On the bottom, v minus 4, v plus 6. And in the middle, v plus 6. What is my LCD? Well, you look at all of this stuff right here, and you start listing out everything you see that's different. So one of the things that I see that's different is a v minus 4. And the highest power that I see for a v minus 4 is a first power, so then that means I'm going to leave it just like that. I also see v plus 6's. That's another factor. And the highest power on the v plus 6's is a first, so there you go. This is my LCD. Okay, that's what I'm going to multiply everything by v minus 4, v plus 6. So I'm going to kind of highlight that for our notes. Okay, now let's go back to the original problem. Let's write it out, factored. So this is 5 over v minus 4, v plus 6 equals 1 over v plus 6 plus 1 over v minus 4, v plus 6. So I just rewrote the original problem factored, that's all. And now I got to do the part where I got to multiply everything by the LCD. So this one takes a little bit of time to write out, so just bear with me here. V minus 4, v plus 6 times 5 over v minus 4, v plus 6 equals v minus 4, v plus 6 times 1 over v plus 6 plus, last one, v minus 4, v plus 6 times, running out of room there, 1 over v minus 4, v plus 6. Again, some of you guys might do this in your head and you don't have to write that out, and that's fine. Okay? I'm just writing it out. That way people that are maybe at home or maybe need to look at this again, they can see what happened. So look at the first fraction. Can I cancel everything out from top and bottom right there? Yeah, v minus 4, v plus 6, it's all gone. What can I cancel on the second one? Just a v plus 6. What about the last one? Everything, right? So here is what it looks like. 5 equals v minus 4 times 1 is just v minus 4. Okay. And then plus 1. So that big old mess just becomes that. So 5 equals v minus 4 plus 1. Or 5 equals v minus 3. And if I add 3 to both sides, I get my answer. 8 is equal to v. And that's 3 of the 6 problems for you guys.